Hello everybody and welcome back to the Fusion 360 for FTC series. This is the 8th video in the series, and if you haven't watched the first 7 videos, I recommend you do so by clicking on the card above. Last video we looked at creating basic 3D shapes from sketch geometry using the extrude, revolve, sweep, and loft tools. In this video we're going to be looking at more complex ways to create geometry, and specifically we're going to be looking at the rib, the web, the hole, the thread, the thicken, and the pattern on path tool. So we're just going to start with the rib, and I'm going to create a sort of L bracket that we're going to work with. So I'm just going to create some rectangles here to form our L bracket, just like this, and then like this, and we can trim away this excess, and there we go, we got it. So I'm going to finish this, and we're going to hit E to extrude, or it's right here, and I'm going to turn on symmetric so the middle stays around the origin. I'm going to make this come out maybe 40, like that. Alright, so we got our L bracket, and now we're going to create another sketch, and we're going to create it on this profile, which is in the center of the L bracket, like this. And we're going to create a line from the top here and from the bottom here. And what this is going to do is it's going to be the sketch profile that we're going to use in the rib command. So the rib command is going to connect these faces in a rib. So if we click here, the first thing it's asking for is a curve. So this is our curve. It's a straight line, but any sort of sketch line will work. So we're going to select that. And now we have some options here. So let's look at the depth options first. So to next will automatically snap it to the nearest geometry. So the nearest geometry is these faces. And so if we create a thickness, that we can look at that. If our rib thickness is 10 millimeters across, and it's automatically snapping to the nearest geometry. If we did a depth, then we would have another arrow appear here, and then we could choose the depth of the rib. So if I make it 10, then it's coming in 10 millimeters. And if we flip the direction, while we have the to next or the depth on, it's going to create a rib on the outside instead of the inside. If we do that with to next, it's just going to completely flip it onto the outside. And the last option that we have here is we have the symmetric versus one direction. If you make it one direction, then the rib isn't going to be centered. It's going to extend out to one side like this. So that's the rib tool. It's useful for quickly creating strong supporting geometry like this, and you don't have to create a new sketch and then extrude out. So it's a very quick way to create this sort of shape. Next, we're going to be looking at the web tool. So for the web tool, I'm going to go back into our sketch, and I'm going to create sort of like a window frame to work with. So I'm going to make a rectangle like this, and I'm going to create another rectangle inside. Actually, let's make this a center rectangle so we can stay around the origin, make things easy, like this, and then one like this. And this is going to be our sort of window frame. I'm going to extrude downwards like this, and there we go, we have it. So the web tool is somewhat similar to the rib tool, where it connects geometry with supports that you define with the sketch. So the first thing that we're going to do is we're going to create a sketch on top of this. We can select the top surface of this window as our plane to work on, or we could select this. It really doesn't matter. I'm just going to go with this for now, just to keep things simple. And I'm going to start creating what my rib wants to look like. So I'm just going to create a very simple like sort of split into 4 sections like this, and I'm not connecting it to the edges, and you'll see why in a little bit. So that's my shape, we're going to finish the sketch, and we're going to drop down here and select the web tool. So the web tool also asks for a curve, so we can select our curves like this. Just get all 4 curves there. And it also has the thickness, flip direction, depth options, and thickness options. So I'm going to leave it on symmetric and 2 next for now, but let's just give it a thickness of 5. And what you'll notice, it has extended this geometry over here from our lines with a thickness of 5, connected it to the walls, and it's gone all the way down and connected it all the way through. And there are multiple options that are making this happen. First, connecting it to the sides is the extend curves option. If we turn this off, you'll notice that it strictly follows the curves that we defined, and it does not extend all the way to the edge. The depth options, right now it's on 2 next, so it's going all the way down. If we did it on depth, we could specify how far it goes down. So if I want to go 10 millimeters down, we would get 10 millimeters down. We still have the symmetric versus one direction options here. That will modify which way it's going. And the last option that we have is the flip direction. I do not believe that it will work. Oh, it did work on this geometry. So it's just flipping it above, so we get it on the outside instead of the inside. So that's the rib tool, the web tool. It can be used with many things. It can be used with many different curves. This is just a very basic example with everything being nice and square. Next, we're going to be getting a bit advanced, and we're going to be looking at the thicken option. And so the first thing I want to do for the thicken option is I want to create sort of like a sort of I'm just going to make an arc to work with for now. So I'm going to make a 3-point arc starting from the origin, specifying the endpoint, and then specify a point on the arc, just like that. And I'm going to finish that sketch, and then I'm going to hop it over to the surface workspace here. I do not use this very often for FTC stuff, but basically instead of creating a object with everything filled in with like solid mass, we're just creating the outside with a mesh. So I'm going to use the revolve tool on this curve, and I'm going to choose the y-axis as my axis to revolve around, and now we have this sort of egg-shaped thing. And we can tell that it's not a solid body if we use the section analysis tool. We'll look at this more later in the screw and the nut example, how to use the section analysis, but if we went in like this, we're seeing into the surface. You can see that it's completely hollow, and it does not give the diagonal lines, which indicates that it's a solid body. So we can use the Thicken tool right here, and what it takes is a face like this, a surface, and now where we have some options here. So chain selection, like always, it automatically selects faces that are touching. The thickness is just how much we're thickening the surface by. So if I went 5, it would be 5. And one side, so right now we're only coming outside. If we did symmetric, we'd be going on the inside as well. And you can see here that this is actually creating a new body here. And so if we jump back here and we did the section analysis on this, and we went in, you could see that it has these hatched lines here, which means that it's solid in those areas. The inside is obviously still hollow because we did not thicken all the way in, but now we can see that we have created a solid body with a hollow inside, and that all just started from revolving that arc around the y-axis. This is a little bit advanced, this tool. I do not find that useful too often, but it's good to know anyways. So let's go back, and now we're going to look at the hole tool. The hole tool is pretty basic. It's about what it sounds like. So I'm going to create a center rectangle here to work with, just like this. And we're going to finish this sketch and extrude it upwards 10 millimeters, let's say. And now we're going to pick the hole tool. It's right here. It's also in the drop down, and the shortcut is H. So the first thing that it asks for is a face. So the face here, I'm going to use this top face. And now it gives me this little blue dragger thing. And I can drag this around and it'll snap to points. So right now it's going to snap to the geometry. That's where I want it. It's the center of this face. The option we have here is the diameter of the hole. And the option we have here is how much we're cutting in. So let's take a look at some of the options that are available here. First of all, we have our distance and two options like usual. Remember that if you want it to stay to face and you want it to update properly, you should use the 2 instead of just clicking with the distance. So I would click 2 and I would click this bottom face, and if we change the thickness of this rectangular prism, it would always change the distance of the hole properly. Now we got some hole types here. These can be useful, very useful in FTC for creating like countersunk and counterbored holes for 3D printed parts or machined parts. And you have some other options that are available here. You can see the hole type and the hole tap type with the drill point, and these are just different options. So if we did flat, if we did an angled like this, you would see that it's angled at the bottom here. If we did flat, it would just be flat. And then there's some, you can do a tapped hole, and you can do a taper tap, you can do a clearance hole. There's lots of things you can do here, and it just makes your job much easier for creating holes. You don't have to worry about did I get the angle for the countersink proper, or is the counter bore enough? And of course there's lots of options down here about, like, if I want an M4 screw, I can select M4, and then there's lots of stuff here. It just makes things easier. I use it a lot. It's a very good tool. And next, which is pretty similar, is the thread tool. So I'm going to create a circle here to work with. And let's actually make it realistic. I'm going to make an M4 thread. So I'm just going to make it 4 millimeters. And I'm going to finish the sketch. And I'm going to extrude upwards 10. And the thread is right underneath the hole. And what you need to select for the thread is a face to apply the thread to. So if this is our threaded portion of our screw, we're going to select this face. And we have some options here. These options are really just like, what screw are you working with? So it automatically knows it's a M4 by 0.7 thread density screw, because we made that 4 millimeter size. If we had made it 6 millimeters, it might be M6. So Fusion tries its best to figure out what you need. There's everything you would ever need here in terms of screw types. Now there are some other options that we can look at. The first is the modeled, and if we clicked OK right now, you might notice that the thread looks kind of weird, and that's actually because it's using a bump map. It's applying fake bump, so it's basically applying a like an image on the top that makes it, on top of this face, that makes it seem like it's threaded. This can be useful if you're working with really large assemblies to create something that looks threaded in a render, but it's not actually threaded. As threads slow down your assembly. If we went back and edited this by right-clicking and clicking Edit Feature, and I'll have a video in the future explaining how to manipulate the timeline, and we click the modeled option, you could see now that it's actually it's modifying the geometry and creating an actual thread here. So this would be an actual thread. And then the other option that I use is the full length option, and this just allows you to create an offset and a length. So since we did 10 millimeters, it's just by default choosing 10, but if we did 5, let's say, it would leave the bottom part unthreaded. And we could choose the offset. If we made it 2, the top 2 would be unthreaded, and the bottom 3 would be unthreaded. So that's the thread tool. Very easy, very useful for creating threads. And this can be used on the inside of something as well. If you have a nut, you can use it on the inside face to create that thread. And this is going to be a very, very, very important tool in our next video when we look at how to create the threads and the shape on the screw and the nut. And the last tool we're going to be looking at is the pattern on path. So I can go ahead and undo this, and we can just use this shape. So we've looked at the rectangular pattern and the circular pattern in sketches. They work just the same with bodies and components. You just select the component, and all the settings are the same. We have not looked at the pattern on path tool. And I'm going to show you as an example just a quick way to make a belt with the pattern on path tool. It's what I'm using very often is creating a belt. So the first thing that we have to do is we have to create our tooth profile. I'm just going to do a rough approximation of what a tooth profile looks like, and I'm just going to choose a arc here with the center point being here, and just like that. And that's going to be the basic tooth profile. We can go ahead and finish a sketch, and we can extrude it upwards, and I'm going to do a 6 millimeter wide belt, so my tooth is going to be 6 millimeters, just like that. And now what we want to do is we want to create a path for this to be patterned around. So I'm going to go ahead and create another sketch here, and I'm going to choose this face. I'm going to rotate it using these arrows up here. You can rotate the way that you're looking. And so this is going to be the bottom here. And what I'm going to do is I'm going to create basically mock pulleys. So I'm going to choose a 2-point circle here, and I'm going to go like this. And my other pulley is going to be over here, just like that. And I can connect these with tangent lines. We can go like this, and we can fix these in place. We apply the fix command to this, and the fix command to this. We can apply tangent. And I just fixed them so we wouldn't have them moving around when we're applying the tangent tool, and just the lines are being moved, just like that. Apply the tangent to the bottom line, just like that. Alright, now we can trim away our extra by just going like this and like this, and now we can create a little offset here, and this is going to be the connecting for the belt. So I've actually got my tooth profile upside down, but let's just go with this for now. I'll just use this to demonstrate how it would work. So the belt is backwards right now with the tooth on the outside instead of being on the inside, but I think you'll get the point anyways. So you can choose different things here, such as faces, bodies, features, and components. We can just leave it on features or bodies. Both of those will work. I'll just put on bodies, and we'll select our tooth here. The next thing it's asking for is a path, and we created this path here. And now we have some options. So we're used to the extent and spacing. So the extent would just be the total distance. If I just do spacing, and I say the spacing between each tooth is 5 millimeters, then we get them spaced out 5 millimeters. And now this is a very, very, very unrealistic belt. Now you may notice that it's not rotating with the path, so I would just change this down here to path direction. And now we could change the amount of teeth by just increasing this value like this, and then maybe we'll just increase it until it looks like we're back to the beginning right there. And you can adjust the start point so it doesn't start at the beginning each time. And if we clicked OK, we would get all these teeth around in the pattern. So this path can be anything. Some paths will be hard to work with, but doing a pattern on path is very useful for just creating a bunch of features along a path without having to do it manually. This is all for this video. I hope you learned something, and hopefully you'll join me in the next video where we will continue working on our screw and nut, and we'll be bringing it into the third dimension now that we've learned all these tools such as extrude and revolve. I'll see you then.